Okay, it's the second day of Greenbuild. I just came from a session on greening your data center. There was a case study of a 60,000 square foot data center that was part of a much larger government campus, about 2 million square feet, that was pursuing LEED certification. And the case study did focus on the data center, but also on how the energy performance of the data center affected the overall energy performance from a LEED standpoint of the campus. They were targeting 30% energy reduction for the campus below ASHRAE 90.1, and having a data center that had 375 watts per square foot of energy use certainly had a big impact on that. This data center was 60,000 square feet, had 1,400 racks that averaged 6 kW per rack, but they also had 25% of the racks were much higher density that had energy usage of up to 20 kW per rack, and how they dealt with that. It's a Tier 2 data center. Actually, they said it was closer to Tier 3, but the electrical redundancy is what got them to Tier 2. Some of the strategies they used in the data center to address the energy performance was they had a chilled water. Chilled beam system, they had some areas that required continuous cooling, so they had UPSs for some of the mechanical equipment, used a flywheel UPS for that, and did chilled water storage as well to provide that continuous cooling that they needed. They increased the supply air temperatures to 65 degrees rather than 52 degrees. They did some supply air temperature controls instead of humidity controls. One of the things I learned, and this may be common knowledge to people who design data centers all the time, was really what the difference between hot aisle containment and cold aisle containment is. This data center used a hot aisle containment system, basically where you use a ducted or a plenum return system and provide cooling to the main space, and then basically direct the hot air up into the plenum area, so it's not lingering in your data space, as opposed to the cold aisle containment, which I guess is a set of little rooms where the racks are in. Those are what's cold, but the rest of the data center area is extremely hot. And basically, you're put in either way. You're controlling where the cold air is going, controlling where the hot air is going, and not having to just blanketly cool the entire space. They used a strategy to basically do a load map of where the racks are, so that they grouped the high density racks together so that they could keep the hot air, or in an event they could keep the hot air going, from contaminating the cold air. They used computational fluid dynamic modeling to basically map how the air paths were going to flow, and that helped them control the space. Some of the other strategies that they used in another data center were direct and indirect evaporative cooling. Obviously, that's a climate-based thing that wouldn't work too well in South Florida. Heat transfer wheels, air-to-air heat exchangers, and then, like I said, the cold aisle containment in that second data center, which was interesting compared to the first data center, which used a hot aisle containment. So that's what I learned about data centers. Actually, the biggest thing is that I didn't mention is that they're really just talking about the HVAC systems in these data centers, and certainly that's a big piece of the load, but the plug loads are not regulated by ASHRAE 90.1, and that's obviously the biggest piece of this data center. The first data center, the first campus that was pursuing LEED certification, when they were all said and done and reduced all their energy throughout the campus, since the plug loads weren't regulated, that ended up being 70% of the overall campus energy use. So that included the plug loads from all the IT spaces. So in this 2 million square foot campus, once they reduced all the HVAC and lighting and domestic hot water loads, all the regulated loads by ASHRAE 90.1, 70% of the remaining loads were the plug loads, essentially. So that just goes to make the point that we really need to figure out how to regulate plug loads throughout these spaces.